Okay, let's get some more derivatives out of the way. Problem set number 4. Y equals e to the mx cosine of nx. I'm hoping by now that you're starting to get tired of seeing these because you're so good at them. Y prime is going to be determined by what? Well, we have a function of x and a function of x, and they're multiplied, so it's going to be product rule. U prime v plus v prime u. What's our u? That's e to the mx. What's u prime? Well, you know the derivative of e to the x is e to the x, but it's also chain rule. And that's going to be just an m. V is cosine of nx. Kind of the same idea. What's the derivative of cosine? Negative sine of the same input. Chain rule times the derivative of the inside function, n. So if I write this out, u prime me to the mx almost looks like a word. That's u prime v, so cosine nx, plus v prime u, negative, let's do negative n sine of nx, like that, and then u, e to the mx. Now let's take the e to the mx out, since it's in everything. We can do m cosine of nx minus n sine. Is it n sine? Sounds like ensign of nx. And that's that one. So that was an easy derivative. That was actually a very easy derivative. It's pretty much just product and chain rule there. It didn't have a lot of craziness. Now the next one has an arcsine in it. Do you remember how to find the derivative of arcsine? Well, if I was to write y equals the arcsine of x, that's the same as saying x equals the sine of y. That's the first step. And now we want to take the derivative of everything with respect to x. So you get 1 equals cosine of y, and then chain rule dy dx. So dy dx is going to equal 1 over cosine of y. And I'm going to remember that cosine squared plus sine squared equals 1. So if I want cosine, you can subtract and take a square root and find that. So what I can say now is that dy dx is equal to 1 over the square root of 1 minus sine squared of y. Now why would I say that? Because that's how we phrased what x is here. So I can now say that dy dx is equal to 1 over the square root of 1 minus x squared. That's the derivative of arcsine. So let's just keep that in mind for a second. So they give us y equals the arcsine of 2x squared. So let's take the derivative. Y prime, what's the outer function? That's exponent rule. So make it 2 arcsine of 2x times the derivative of the inside, which is this arcsine, which is going to be 1 over the square root of 1 minus 2x squared. This is the input, not just x no matter what, times the derivative of the inside. Again, there's another inside, and that's just a 2. So we're going to get y prime equals 4, this 2 and this 2, arcsine, oh, that's ugly. Let's make it nicer. Let's make it nicer. 4 arcsine of 2x over the square root of 1 minus 4x squared. That'll be the answer for the arcsine problem. So what we notice with this one is that there's an outside function, an inside function, and an inside function. And it's good to know your derivative ahead of time, which would be this one. You can use a cheat sheet on your test, usually in Calc 1, but it wasn't hard to derive that, was it? It's a little of the implicit differentiation. I think it's really important that you be able to do that. I can't tell you how helpful it'll be in Calc 2 to be able to do that. Okay, what's next on our list here? Let's cross those off with pride. Wink, wink. Okay. Y equals the natural log of secant of x. Now, I can never remember the derivative of secant, and I know I'm going to need it, so I'm going to remember that it's 1 over cosine of x. We can use the quotient rule, which is u prime v minus v prime u over v squared. Our u is 1, but our u prime is 0, so this whole term will be gone. We get minus v prime cosine becomes a negative sign, so that becomes a plus sign of x, times u, which is 1, over v squared, which is cosine squared of x. And you know I hate putting the exponent there, but for the review, we're going to do it the book way. So that is secant, i.e. a 1 over cosine, times a sine over a cosine, that's a tangent. So the derivative is secant tangent. Just remember that. The derivative of secant is secant tangent. Let's bring that in here. Should be something you know just because you've done a lot of these homework problems over the semester, but if you're cramming, you might want to be able to derive it instead. Outside function, natural log, that's 1 over the input, 1 over secant of x, times the derivative of the inside. Well, what's the derivative of secant? That's secant x tangent x. So these will cancel, and I believe we get y prime is equal to tangent of x. And that's really cool to know that the derivative of the natural log of secant is tangent. Let's cross it off. Zap. Feel good about that one too. Now the next one seems a little obvious to me, but we'll see if there's some difficulty with it. Y equals u minus 1 over u squared plus u plus 1 to the fourth. So what do we want to pay attention to? Right away I'm looking at all this stuff in here, but that's not what we need to pay attention to at all. We're taking a derivative. It's a power rule. You know that. We don't even need to look at the inside function yet. Right? That's the whole thing. And then it's times the derivative of the input. And this is where we got to do our quotient rule. Maybe I'll come down here and do it. We'll just write it out. U prime, what's u minus 1? Well, the prime of that is just 1. V, u squared plus u plus 1, minus v prime, that's 2u plus 1, times the numerator, u minus 1, divided by v squared. U squared plus u plus 1 squared. Now if I want to simplify a little bit, we might write it like this. Let's FOIL that one. That's a 2u squared. Minus 2u and plus u is minus u minus 1 over u squared plus u plus 1 to the fifth. So that's ugly, but I don't know that we have any reason to go farther than that with it. That's pretty cool looking. I guess we could put this one together here. You want to clean it up just a little bit more? Let's clean it up just a little bit more for the sake of algebraic completionism. That's a nerd way of saying I like doing math for no reason. Plus u minus minus u is a plus 2u. Don't make that mistake. 1 minus minus 1 is plus 2. Over u squared plus u plus 1 to the fifth. Let's call it on that one. And that'll probably make problem set number 4. I'd say we can cross this one off, call it good there. What do you think? Leave me a comment if you actually made it to the end of the video.